ngiyezwakala yeah angibonile ukuthi lento yethu ya trend man iyangithusa
come on so ukuthi baba akakhokha khona manje akhokhela ekuyiyona azoyitrendiswana lo trend wenza abantu ababazi umuntu ebona mhlawumbe nobonke eshare lo
phela iqala kanjalo indaba yeah
khona indlela ama-esa akhokhela ukuthi
kufanele kube ngaka hayi ulungile azisho sesingaqala namhlanje we'll look at examination type questions on acids and base. The question lena engibhale lana some of the things ngizozamchaza nje at length but kokunye nje so refer nje kule message kule lento kade siyenza ngaphambilini. Now here they say the labels on four bottles in the laboratory. Ngiyaqolisa ukuthi bottles is bottles. Mine said the bottle, bottle. The labels of 4 bottles in the laboratory reads as follows. Number A is sodium hydroxide, 0.2 mole per cubic decimeter. Since by the mole per cubic decimeter, it means that is the concentration of sodium hydroxide. B is nitric acid, 0.2 mole per cubic decimeter. Nayo okushitshela ukuthi nayo it's a concentration is nitric acid. Carbonic acid, not carbonic, sorry, it's vinegar leyo, ethanoic acid. Now concentration yakona is 0.2 mole per cubic decimeter, and ammonia concentration yakona is 0.2 mole per cubic decimeter. Now bayabuza ke 1.1, which of the above mentioned substances are classified as monoprotic? Monoprotic siyakhumbula ukuthi yile ekwazi ukudonate ngu-H plus owodwa bese kuphelele kanjani. It can only donate, that is a substance that can donate with one H plus, and then that's the thing, that's the end of it. So obviously number A is not an acid, it's a base, because as it dissociates it forms OH minus, and according to Arrhenius the OH minus ileyo substance, the base ileyo substance that forms OH minus when it dissociates in water. Let's see number B, HNO3. Oh, perfect. Number B, it's monoprotic. Number B is monoprotic because if HNO3 dissociates in water, it forms H plus aqueous and OH and NO3 minus aqueous. Or we can say, if we don't want to say H plus aqueous, we can say H3O plus. That is hydronium ion. This is H plus in water. Let me zoom. See, I zoom lento. Sesizuma sesizothi H plus in water. That is aqueous. We have H3O plus. That H ingenela phana emanzini yandisa inamba ka H and the charge, so it's hydronium ion. So whether you say H plus aqueous or H3O plus, you still mean one and the same thing. But don't say H3O plus aqueous. You must say H plus aqueous or H3O plus. Right. What about number C? Number C is also a monoprotic. Why? We know, we said before, H3COOH in water will also give us H plus aqueous and CH3COO minus. So it can only donate null hydrogen, not these. You remember I said these hydrogens are bonded to carbon, and the bond between carbon and hydrogen is very strong, so it won't donate with this hydrogen. It looks mawibuga in about hydrogen about 4, but when it dissociates, when it donates, it can only donate with 1 H plus. So this is a monoprotic. What about NH3? Oh, NH3, it's very impossible for it to donate nitrogen number. So our monoprotic acids, it's B and C. These substances, that is B, nitric acid, and ethanoic acid. Please pay a lot of attention to this one, because it donates with H plus or water lona, but not nalababu hydrogen abalapana. So it is classified as a monoprotic. So this is how we should look at it. But now when you answer it well, you can write all those stuff, but you say B and C, which one of B and C, but you must know what lawyer B and C uzeganjan. Let's look at number 2, 1.2. Write down an expression for a Ka value of these acids. An expression of a Ka value of these acids. Mesizokwenza ama K equilibrium. Mesikhumbula kahle. Mesizochecka lapana we'll be doing. We say Ka, it's what? It's concentration of products. It's a ratio between concentration of products as against concentration of reactants. Concentration of products as against concentration of reactants. Let us look at the first one, HNO3 in water. Once it reacts with water, it forms what? It forms H3O plus plus NO3 minus. Now what is the expression for Kc of this one? We know that Kc in this case is Ka because it's constant of an acid. Ka is concentration of products as against concentration of reactants. Concentration of products as against concentration of reactants. So what is concentration of products? It's H3O plus concentration times NO3 minus concentration over reactants. It's HN concentration of NO3, HNO3. I hope yabonakala lapho, HNO3 and H2O. If H2O is a liquid, we don't include that. But if it's a gas, if we assume it's a gas, then we can include that. So but we have to write it like this. So this is for number B. For number B, that is an expression for Ka value. Now they say write down an expression for Ka value of these acid or acids. Yabonake nwenake uthola ama acids awu 2, so it must be 2. So lo S lo benzela khona ukuthi muthole yodwa awubhale yodwa phela kodwa empeleni zu 2. That is why bathi acid bathi mhlawumbe acids. So with us it's acids. Yiphi acid now? Number C. Uthini number C wethu now? It's CH3COOH plus H2O. It forms H3O plus CH3COO minus. What is an expression for Ka? Ka says bonile. What is its concentration of H3O plus and CH3COO minus? These are products over what is a constant reactance is concentration of CH3COOH as times H2O. We know the conditions of putting all these using the law of mass action. We'll come back to that one as we do rates of reaction and chemical equilibrium. But this is how one should write the Ka value for 1.2. Then we go to 1.3. Asusutsela 1.2 sesiyahlupheka kuhle njengoba noma ngisusa ngeke ungistop uthi hayi bengisabhala wena uzorewind nje urewind ubheke futhi kabusha kube mnandi ungathi hayi awenzani lo awenzani ngisabhala hayi wena uzorewind laphana kwi-cellphone yakho hayi uma ingekho ke lapho rewind khona asoyofuna uyothenga entsha yini na i-cellphone. What is the difference between a strong acid and a concentrated acid? A strong acid yileyo substance that dissociates almost completely in water. That is a strong acid. If you take a substance that dissociates almost completely in water, one of the products may say dissociate almost completely, it forms H+. That's a strong acid. For instance, HCl is a strong acid. Ngoba to HCl emanzini in water, it dissociates H+ aqueous and Cl- aqueous. Or we can say HCl plus water, it forms H3O plus and Cl- aqueous. So we have that HCl in water, so it dissociates completely. Then that is a strong acid. Any substance that when it dissociates in water, it forms H+ as one of the products and the other ion, but it dissociates completely. That's a strong acid. But what about a concentrated acid? A concentrated acid, it's any substance that is more, it's more of itself, that substance that can form H+, but iningi ukudlula is solvent. Yeah, it's more than amanzi. In this case, we use water as solvent. So if you have a high concentration of acid, which means it's more than its solvent. So iningi yona ukudlula lento eyihlakazayo. So that's a concentrated acid. So we can still have a weak acid being concentrated. We can have a strong acid being concentrated. We can have a weak acid being dilute, a strong acid being dilute. But in our case, we have a concentrated acid is that substance that can form H+, but where it's more of that substance more than a solvent. In our case, we use a solvent as water. So it's high in volume than a solvent. So that is a concentrated acid. 1.4. Which of these substances has the highest pH value? Highest pH value. So if the pH value is high, obviously lower acids lower, the pH value is low. Acids is less than 7. But look at number A, sodium hydroxide. It forms OH minus. So if OH minus are produced in the solution, then that OH minus increases the pH value. So it becomes more than 7. So sodium hydroxide, we know, sodium hydroxide, let me write it there, with a skombuzane, theorize, sodium hydroxide in water, it forms Na plus aqueous and OH minus aqueous. So we have seeing that this one forms OH minus. This increases the pH. As we have more OH minus in the solution, then the potency of hydrogen becomes more. So the pH is high. So this number 1.4, the one with the highest pH value, obviously is sodium hydroxide. 1.5. Sihlabela mgama asho njalo amaXhosa athini na sihlabela kuphi na mgama hayi kagama kodwa kuphi mgama. 1.5 consider compound A if it dissociates completely in aqueous solution, right? Yeah. 1.5 consider this if it dissociates completely, it dissociates yonke in an aqueous solution, it forms that. Oh, but wait, consider that if it dissociates completely in an aqueous solution. Determine the concentration of hydroxide ion. What is the concentration of OH minus? Ingakanani on the concentration of sodium hydroxide? Sodium hydroxide 0.2 mole per cubic decimeter. Oh, if one produces 1 and 1, OH manje. If one produces 1, so 0.2 mole per cubic decimeter will also produce 0.2 mole per cubic decimeter. Oh, but the ratio is the same. 1 mole of sodium hydroxide produces 1 mole of OH minus. So 0.2 will give us 0.2. That is the concentration of OH minus. So we have this. So the concentration of OH minus is 0.2 mole per cubic decimeter. Right. Now calculate. Consider, determine now the concentration of hydronium ions. The concentration of hydronium ions. Let's work it like this. We know that the Ka value here too it's 1 times 10 to the power minus 14. So what is 1 times 10? 1 times 10 or 10 to the power minus 14 is equals to concentration of OH minus times concentration of hydronium ion, or it can be H plus aqueous. H plus aqueous. Motada, you can use that or that one. Then what do we have? We have, what is concentration of that? 10 to the power minus 14. It's our constant value. Then what do we have? OH minus is 0.2 times concentration of H3O plus. So I guess check it. We have concentration of H3O plus hydronium ion. Abanye bathi oxonium ion, abanye bathi hydrated hydrogen. Then we have 10 to the power minus 14 divided by 0.2. What do you have? What is concentration of hydronium ion? Let's check lapho. Sitholani na 10 to the power minus 14. Ngithola la 5 times 10 to the power minus 14. 5 times 10 to the power minus 14 mole per cubic decimeter. That is the concentration of H3O plus. Oh, yes, I'm going to do that part. Okay, so that is the concentration of H3O plus. So this is how we got that answer. The pH of the compound. What is the pH of the compound? The pH it's minus log the concentration of H3O plus. So minus log the concentration of H3O plus. So sizothi a pH is 13.30. That is the pH. Yayibona ke ukuthi inkulu kangakanani pH yakhona 13,3, which shows ukuthi it is the substance that has a highest pH value 13,3. Niyazi phela pH ranges between 0 and 14. So we have this 13,3. 1.6. Which solution will react to form a salt with a pH which is less than 7? Yiphi solution that can react to form a pH which is less than 7? Form a pH which is less than 7, which means that pH, that solution will be acidic. It will be acidic. Which solution, which two solutions will react to form a salt with a pH which is less than 7? Two solutions, obviously. Lena will react to form ngoba izonikeza OH plus kwi solution. And then what about ammonia? Why not this one? This one, acetic acid, it forms CH3COO minus plus H plus aqueous. Acetic acid in water, it gives us acetate ion and COO minus. But now the problem comes if acetate ion in water, it's a strong conjugated base of a weak acid. So mengena solution that acetate ion is in water plus H2O. It's a strong conjugated base. It will readily accept H plus. It will take H plus because it's a strong conjugated base. It will take H plus from water. Bese isakhela nina CH3 COO H. You'll to H plus from there. Bese kusala kuyini OH minus. So ukwakheka kwa OH minus iyokwenza ukuthi the pH ibe greater than 7. What about NH3? NH3 uma ingene emanzini NH3 will readily it will act amanzi will accept will donate H plus to NH3 to give us NH4 plus what? Plus OH. In fact, NH3 it's a stronger acid, but beg your pardon, NH3 it's a stronger acid. It will donate H plus emanzini, then it will form NH2 plus, NH2 minus, and then we'll have H3O plus. So the two salts that can react, the two solutions that can react to form a salt of pH that less than 7, B, it's NH3, and HNO3, it's B, and our D, P and D, these are the solutions that will give us a low pH, a pH which is less than 7. It cannot be this one, but this one as ngikhombisile izokwenza ukuthi solution then we'll have HNO3. But if it's ammonia in water, ammonia will donate with H plus, then a lot of hydronium ion will be formed, hence decreasing the pH of the solution. So it's B and D. I guess 1.7. Let's go to 1.7. Now they say, assume 10 cubic centimeter of A, 10 cubic centimeter of A, concentration of A, or volume of A is 10 cubic centimeter. Assume that 10 cubic centimeter of A, we know the concentration of A. The concentration of A is 0,2. You take this 0,2 mole per decimeter cubed. So we have 10 cubic centimeter, and a concentration of 0,2 mole per decimeter cubed, and is diluted. You dilute that to 30. Then now we say VA again. Let's say Lana is before dilution, and then what about after dilution? After dilution is diluted by kubanisa namanzi bese ibangakanani na about 30 cubic centimeter. Determine the new sodium hydroxide concentration. What will be the new concentration? Now listen to this one. We know before dilution, in the concentration ka A, volume ka A, the concentration ka A, which means nama number of moles ka A, our concentration ka A, the volume ka A, ama number of moles ala. But listen to this one. The same solution by dilute. Maybe dilute kushintsha i-volume. Mokushintsha i-volume in a concentration izoshintsha as long as the number of moles remain the same. Why do we say they will remain the same? Ayikhishwanga leyo solution ku-add nje amanzi, which means ama number of moles ala is the same number of moles alaphana. Ayikhishwanga leyo solution. Okwenzekile nje kuleyo solution yayilapho kuthelwe nje amanzi yadilutwa, okusitshela ukuthi ngale nkathi volume iba more. Look at the relationship C and V. If the volume is increased, sesilindele concentration should be less than 0,2. Ngilindele lokho nami ngoba ngiyazi ukuthi uma ku-equation i-relationship is like that, multiply the two. If one of them increases, the other one decreases. They are inversely proportional, provided this is kept constant. And obviously, our number of moles of acid now is kept constant. Now, ngoba number of moles of acid yala is the same number of moles of acid yala. It's number of moles of acid, number of moles of A, sorry. Number of moles, this is volume of A, it's not acid, but wait, volume of A, concentration of A. Volume of A, concentration of A. So number of moles of A yala is the same as number of moles of A yala. Then what do we have? We'll have CaVA, we equate the two, will be, this is before dilution, then it's CaVA after dilution. Very tricky question, but wait, after dilution, very tricky question. Ungayi ngobuso, ungabuya ungesenabo unina ubuso. So we have CaVA. So what is Ca is 0,2 times 10 is equals to Ca after dilution, sifuna yona, Ca after dilution times volume 30. Then what do we have? We'll have 0,2 times 10, which is 2, divided by 30. That is concentration of the acid, of A, of sodium hydroxide. So what is concentration yala? Then what do we have? 2 divided by 30. So we'll have something like 2 divided by 30. Let me not 2 divided by 30, then I get 0,0667. So, which is concentration of solution A, it's 0,0667 mole per cubic decimeter. That is the concentration. The concentration has decreased from 0,2 to 0,0667 mole per cubic decimeter. Then Babu Zabati, and hence predict with reason whether the pH will increase or will decrease. If the pH, if the concentration, yes, sodium hydroxide, we need to predict now. If the concentration of sodium hydroxide becomes less, it means less OH minus are formed. If less OH minus are formed, then the pH will go down, or more of H plus will be produced. So we know that as the concentration, this being a base, as the concentration of the base decreases, it means less amount of OH minus, and if the OH minus in the solution decreases, then this decreases the pH of the solution. If more OH minus, if our OH minus baba more in the solution, then this increases the pH of the solution.